Dear students and my teacher friends, Namaskar. I welcome you to the presentation lecture on semicircular ducts. Now, as you know, in our body, there are two ears, left and right, and in this two ear, there present the semicircular duct. Now, how many semicircular ducts are there in our body, and what are the function, what are the role of the semicircular ducts are playing in our body that we are going to discuss in this lecture. So, starting with the first point, see there are total three semicircular duct in each ear, and these three semicircular duct they lie at right angle to one another, and they are present in three planes. So there are, in short, there are three semicircular duct, and the angle between them is right angle. That means 90-degree angle is there. So let me show you this three semicircular duct. So here in this figure, as you can see, these are three semicircular canal, and in this canals with the pink color, these are the semicircular duct. Okay, now uh, two semicircular duct they are present vertically, so there are two vertical duct, this, and they are known as anterior and posterior semicircular duct. So anterior and posterior, this one, for example, this one is the anterior semicircular duct, and this one is posterior semicircular duct, and they are the vertical duct. Whereas the lateral, okay, this one is the lateral semicircular duct, and lateral semicircular duct is the horizontal one. So it is present horizontally. So let me show you this figure, and in this figure you can see the three semicircular duct. Two are vertical, one is horizontal. Anterior posterior vertical duct, lateral semicircular duct is the horizontal one. Okay, now the positioning of this three duct permit us the detection of rotational acceleration or deceleration. So now what is rotational acceleration and deceleration? See, when we are rotating our head in a circular path, let's say we are dancing, okay, on a circular path we are dancing, that means our body is spinning, okay, our body is spinning circularly, okay. So that spinning dance, we can say, is the rotational acceleration, because when we are dancing, when we are spinning our body, that time we are going to accelerate, so that will be rotational acceleration. And what is rotational deceleration? So we are not going to dance continuously. After some time, what will happen, the dancing speed of our body is going to decrease, and gradually we are going to stop our body, okay. So that is known as rotational deceleration, when we are decreasing our speed. Now we are moving forward, and we are discussing the third point. Now see, as we have discussed, there are three semicircular duct, and in each duct one dilated portion is present, and this dilated portion is known as ampulla. So here you can see these are the three three duct they are showing, and with the blue color you can see this blue color portion is the dilated portion, and this dilated portion is known as ampulla. Now in the ampulla, inside the ampulla, ampulla contains small elevated region. Okay, so inside the ampulla, what is there? Inside the ampulla, small elevation is there, and this small elevation is known as crista. Crista equal to crest, plural is cristae. So in this figure, see, they have zoomed this ampulla, and this ampulla is zoomed and they are showing over here. So this is the entire ampulla part they are showing, and here as you can see in the ampulla elevation is there, and this elevation is known as crista. So this elevation, okay, this is the crista. Okay, so this is the third point of our discussion. Let me show you this entire figure. Now what is there in the crista, what the crista is made up of? So each crista consists of group of hair cell. So with the blue color, as you can see, they are showing us the hair cell. So these are all hair cell. So in the structure of crista, hair cells are there, and along with the hair cell, supporting cells are also present. So in between the hair cell you will find the supporting cells are also there in the crista. So this is the fourth point of our discussion. Now we are discussing the fifth point. Now this point we have already discussed in our previous lecture. Now here again we are discussing this point. See, here in this figure hair cell are shown, and on the top surface of the hair cell kinocilium is there. So this is the kinocilium, and stereocilia are present. So these are all stereocilia. Okay, now together the stereocilia and kinocilium collectively they are known as hair bundle. So here you can see these are all stereocilia and this is kinocilium. So this bundle, okay, this bundle is known as hair bundle. Okay, this is the hair bundle, name is written, and the stereocilia are interconnected via tippling. So this one is stereocilia, this one is stereocilia, this one stereocilia, and this is the tippling they are showing. So this is the tippling. Okay, so stereocilia are interconnected via tipplings. Now we are discussing the sixth point. Now covering the crista, see this is the crista, okay, and covering the crista is a mass of gelatinous material. So here this you can see this is the mass of a gelatinous material, and this mass is known as cupula. Okay, so once again crista is covered by mass of gelatinous material which is known as cupula. So this one is the cupula. Okay, now seventh point. now now when our head rotates, okay, so the attached semicircular duct and hair cell move with it. So when our head is rotating, that time along with our head, semicircular duct and hair cell also moving. However, endolymph within the ampulla is not attached. So endolymph is a free fluid, and this endolymph lags behind due to inertia. Okay, so what happened? Initially, the endolymph is not moving. When see, endolymph is a fluid, but as we start, so it is lagging behind. It will take some time to move this endolymph. It is not that the moment we start, the fraction of second that we rotate our head, so the endolymph is moving. It will move, but after some moment of time. Okay, so this lag period is due to the inertia. Okay, so now as the endolymph is dragging, this drag of the endolymph causes the cupula and the hair bundle that project it to bend in the direction opposite to that of the head movement. Okay, so what happened, see, the direction in which you are rotating your head, so opposite to that direction, opposite to your head rotation, the cupula and hair bundle, they are going to bend in opposite direction. So cupula and hair bundle move opposite to the head movement. Okay, so here once again, let's see this figure. Okay, you see ampulla cut open, crista ampullaris they are showing, semicircular duct. Okay, and here you see this girl, and right now the girl's body is in a resting position. Okay, now in the resting condition, see, crista, you see the position of crista, entire crista ampullaris they are showing. Okay, then you see the cupula, the position of cupula, the endolymph you see, hair cell, position of hair cell you see, supporting cell position you see, and yellow color they are showing the sensory nerve fibers. Now now here in this figure, see, now the girl has started to dance, and she is doing rotational dance. Okay, circular path, she is dancing. So when the girl is dancing, so due to the rotational movement, see, with the arrow they are showing us the direction of head rotation, and the endolymph lags behind. So as the endolymph lags behind because of inertia, so this endolymph is pushing the cupula. So here you can see the cupula is pushed over. Okay, and you see the bending in which direction the cupula is bent when the head is rotated. Okay, so you can see the direction of head rotation and the direction of a cupula bending is opposite. Okay, so hair cell are also bend in opposite direction to our head. Okay, so this is the entire figure. Okay. One more figure I would like to show you. See in this figure, okay, see anatomy of crista ampullaris in a semicircular duct. So in this figure, see here you see the endolymph, hair bundle, kinocilium plus stereocilia, hair cell they are showing us, supporting cell, crista ampullaris, fibers of vestibular nerve, then scanning electron micrograph of a crista ampullaris. Now here you can see the girl is in a resting position. So at rest you first you see the position. So the cupula stands upright. Okay, so you see the ampullary cupula, then the endolymph they are showing, then the fibers of vestibular nerves are shown. Now you see the girl is dancing, and rotational dance she is performing. So her body is spinning, okay, and this is the direction, see, in which her body is moving. So you can understand the rotation of head rotation direction this way, okay, with the arrow. So now what happened? endolymph is flowing. See, this is the body rotation direction, head rotation direction, and you see the flow of endolymph. So when the girl is dancing, what happened? The endolymph is flowing in opposite direction. So as the endolymph flows in opposite direction, what happened? See, during, here it is written, during rotational acceleration, endolymph moves inside the semicircular canal in the direction opposite the rotation. And why this happened? Because the endolymph lags behind due to inertia. Endolymph flow, as the endolymph is flowing, endolymph bends the cupula, and this bending of cupula excites the hair cells. Okay, now here, now what happens? This is the third position, and now here the girl was dancing with her full energy, and after some time she is going to decrease her speed of dancing. Okay, so when she is decreasing her speed for dancing, that time the rotational movement is slowing down now. So now endolymph keeps moving in direction of rotation. Okay, so during deceleration, what is happening? Endolymph is moving, but now it is in the direction of rotation. Now endolymph flow bend the cupula. So now during deceleration, when the body is slowing, that time what happened? Endolymph is flowing in opposite direction. Okay, so this endolymph flow bending the cupula, but in the opposite direction from the acceleration. Okay, so now during deceleration, the endolymph is moving in opposite direction, and as you can see the cupula also bending in opposite direction. So this opposite direction bending of cupula inhibit the hair cell. Okay. So let me show you this entire figure. See, now let's just read this point. What they are saying is, see, if the head continues to move at a steady pace, the endolymph begin to move at the same rate as the rest of the head. So this causes the cupula and its embedded hair bundle to stop bending and to return to their resting position. We have already discussed this thing. Okay, now let me read this point also. Now when the head stops moving, when the girl stops dancing, so when the head stops moving, the endolymph still temporarily keeps moving due to inertia. And as the endolymph is still moving, uh, this causes the capula and its hair bundle to bend in the same direction in which earlier the head movement was. Okay, so at some point the endolymph stop moving and the capula and its hair bundle return to their resting unbent position. So finally endolymph stop moving. That time capula and hair cell bundle return to their resting unbent position. Now let's discuss the point number 10th. 10th point we are discussing now. See, let me show you this figure. Okay, first you see this figure, semicircular duct, ampullae, and here see crista ampullaris, then cupula they are showing, kinocilium, stereocilium, hair cell, supporting cell, and the fibers of vestibular nerve they are showing. Okay. Now here in this figure you can see girl's head is stationary. So when the girl's head is stationary, that time you see the endolymph position of cupula, you see stereocilium, you see hair cell position, you see. Okay, and uh, here they are showing action potential. Okay, so all these vertical lines, what these lines are showing, the strength of action potential they are showing. Okay, so the nerve signal or the nerve impulse which is going to generate that, they are the strength of that nerve impulse they are showing with this vertical lines. And here as you can see, when the girl's head is turning, so that time, so when the girl's head turn, so see now what happened, endolymph legs behind and moves in the opposite direction from the way the head turned. Okay, now this endolymph is pushing the cupula, and this pushing of cupula, so the hair cell are bending, hair cell are bending, so hair cell are depolarized, and as the hair cell are depolarized, they release the neurotransmitter glutamate. So now hair cells are depolarized when the head is rotating, they are producing more glutamate. Okay, so when the hair cell are depolarized, you see the strength of action potential. Okay, so now impulse are generated, more now impulse are generated, and they are the stronger one. And here, when the head stop turning, so when the head stop turning, that time, see, the head the and in the head, the endoleaf still continues to move in the same direction as the head was turned, which hyperpolarizes the hair cell. And as the hair cells are hyperpolarized, they are producing less glutamate. Okay, so now this is the 10th point. See, not that bending the hair bundle in one direction depolarize the hair cell, and bending in the opposite direction hyperpolarize the cell. The hair cells synapse with first order sensory neurons. Okay, hair cell, they are synapsing with the first order sensory neuron of the vestibular branch of the vestibulocochlear nerve. So we know this in the previous lecture also, we have studied this point. Okay, once again I will show you the figure for this point. 1 minute, one more figure I would like to show you. Okay, now you see in this figure, see in this figure first, uh, you see this gentleman. Okay, and he is having a very nice smiley face, and now he is rotating his head. Okay, so first figure, head is stationary, and in second figure, head is rotated. Okay, so now you see the direction of head rotation, and you see the bending of cupula, so it is in opposite direction. And now we know, see, this is the cupula they are showing, and see, type 1 type 2 hair cell they are showing. And we know in the previous lecture also we have discussed that this yellow color cell are the primary sensory neuron or the afferent neuron. Okay, and this green color cell are the efferent neuron. So the synapse and connection and the nerve formation we have already discussed in the previous lecture also. So in short, this yellow color cell which are synapting with the hair cell, okay, are the primary sensory neuron, and the green color cell, they are the efferent neuron. And here the neurotransmitter which is released is glutamate. Okay, when the head is rotating and the hair cell are depolarized, that time. So now let me show you this entire figure so that you can see it clearly. Now here, see, the ampullas are shown. Okay, these are the ampullas, and now inside the ampulla we know the hair cell. See, hair cell, as we have seen in the previous figure, hair cell synapse with the yellow color cell was first order sensory neuron, and this sensory neuron and efferent neuron, they form the vestibular branch of the vestibulocochlear nerve. So here you can see this entire, okay. So see, vestibulocochlear nerve having two branch. So this branch is vestibular branch, and this branch is the cochlear branch. These two branch merge together, okay, and this nerve which is formed is known as, vestibulocochlear nerve, nerve number 8, cranial nerve. And here, see, the hair cell synapse with first order sensory neuron of the vestibular branch of the vestibular cochlear nerve. Now hair cell are depolarized, so there is a greater frequency of action potential generated, more neurotransmitter is released, okay? And during hyperpolarized, less neurotransmitter is going to release, so there will be less generation of action potential, okay. So the primary sensory neuron, okay, first order sensory neuron and their axon, okay, their axon, they bundle together and they form the vestibular branch of vestibulocochlear nerve, okay. And this nerve will send the nerve impulses to the brain center. Now we have discussed all the theory point of this lecture. Now I would like to show you all the figures, okay. So I'm showing you the remaining figures. This we have seen, okay. We have seen this figure, okay. This figure, see, okay, semicircular canal. In this figure, ampulla. Now in this figure you see, okay. See, I have tried to explain you all theory point, but just in case you are having some doubt, so you can read this, okay, and you try to understand this A B C D E figure, so you will get your point, okay. See, organization of a cupula and ampulla. Figure A and figure B, relation of the cupula to ampulla when head is at rest and when it is accelerating. So at rest, accelerating, rotation of head. Now this is a histological slide. Okay, so here you can see cupula, hair cell, sensory epithelium, supporting cell, nerve fiber, connective tissue, bone. And here also in this figure, see cochlea. Okay, then the vestibule, utricle, saccule, cochlear nerve. So, see, in the previous lecture we have discussed this thing, autolytic membrane. Okay, hair cell, supporting cell, nerve fibers. So this figure, photo, micrograph of the crista ampullaris and macula of utricle of the inner ear. See, head still and then head rotating. Okay, ampulla position. Okay, capula position, you see cupula, and you see axon of vestibular branch of cranial nerve 8. Okay, and here you can see during depolarization, so now signal sent to brain. Okay. So with this we have completed this lecture on semicircular duct. I hope you have enjoyed this lecture, and I also hope that this lecture will be helpful in your exam preparation and also in your studies. My name is Manish Kostisar. I am from Ahmedabad, India. Bye bye. Namaste.